Very good morning to students. Today there is a new topic where drills using in the Opencast mines for the making of the blast holes per other borehole, making of the boreholes for different purpose. Most of the Opencast mine is particularly making of the blast holes to preparation of the hole for the blasting, for which you require different type of drills that you are going to today topic. So my name is Karuna Kumar. HOD mining, missionary employed in the surface mining is a topic, and subtopic is the list of different drill missions with respect to their depth and diameters. So basic objective after completion of this topic, you will be able to list the different drill missions with respect to their depth and diameter ranges. Drilling of rock for blasting purpose is an essential requirement today in the breaking of the medium hard rock and hard rocks. In the olden days, hard rock were broken by means of driving wedges through the cracks, sledge, hammering, or exploitation the rock by heating. It's with fire built against the then quenching with the water. So this is the olden days practice. What are the weak planes that, according to making the hammering and exploiting the by the rock with the heating treatment. Uh, but nowadays the huge blastings for preparation required the making of the hole is required. Today experiments are underway for utilization of the ultrasonic way also, high frequency electricity or thermal energy for breaking rock in situ. But no method has yet to be commercially successful, so that hard rock has to be drilled for excavation. So there is a number of models or R&D works on the making of holes are through the thermal energy breaking and ultrasonic waves that is experiment purpose. So presently, that is only the for the universal accepted method is the only drilling. Drill holes for blasting purpose can be a small 40 to 50 mm or large 65 to 300 mm diameter required depending upon the requirement of the mine. Larger holes of over 800 mm diameter are sometimes drilled for the purpose of ventilation, conveying of fill or timber, installation of the pipes, cables, etc. in underground mines. While large diameter holes may vary from few meters to over 50 meter in depth, mainly used for the bench drilling in open pits. Small diameter holes can be short or long, 6 to 25-meter long. Short narrow holes are generally used in a narrow underground working or small open pit with the short benches. This is the practice general hole dimension is concerned. Nowadays, most of the Opencast 300 mm, almost 30 centimeters holes nowadays going on. Then almost our scale, small scale diameter. Cable for installation purpose in underground also we are making for the drill is required. For large diameter holes may vary from the few meters to the over 50-meter depth may be used for the bench drilling in open cast mines. Short narrow holes are general or is narrow for the underground purpose. But here our question is only for open cast. We will go through the open cast related missions only. Very short holes of only 150 to 200 mm length are often used for secondary blasting boulders in both open cast and underground workings. Long narrow holes generally find use in the sublevel stopes with the long hole blasting and snake holes at the top bench in the open pits. Sometimes they may be used for primary blasting of all tall benches in open pits with a small burden, but open pit primary blasting generally is used for the large diameter holes. Method of drilling can be classified as follows. So what are these are the purpose, basic purpose of drills. They go two sides to understand, and the range of size of the drill diameter is also depending upon the requirement, whether you go to short holes or long hole. The range, the diameter of range also, depending upon the usage, the blasting phenomena accordingly. But what are the methodology? Methodology for particular drills can be classified as follows. Rotary drilling with the drag bits, with the roller bits, with the diamond bits. Rarely used for the blast holes. Most of the diamond bits are for bore holes purpose, but the drag exploration purpose. These are the for exploration drilling. Diamond drilling bits are used with the drag bits. Rotary drilling drag bits are most popular with the roller bits. Percussive drilling. Percussive drilling. Piston drills now absolutely hammer drills, handheld, pneumatic pusher mounted, bar or column mounted, wagon or carriage mounted, churn drills. These are the basic drilling machines are used. Percussive drilling, piston drilling, hammer drilling, handheld drilling, pneumatic pusher mounted, bar and column mounted, wagon or carriage mounted. The churn drill. Rotary percussive drill. The conventional type with the drag chisel bit with the roller bit. Down the hole drill, hole type, thermal drilling or jet percing. Introduction. Drilling is performed in order to blast the overburden, over deposit, coal seams, etc. So the power requirement for excavators or extracted the material become the less. This also reduce wear and tear of the excavators, increase their life, reducing cleaning time of material and decreasing operating cost. Drilling holes are usually made in a zigzag pattern. The specific between the rows and columns is of the equal length. Certain empirical rules are followed for this specific uh, depth holes and indicated below. For hard rock, it is a 1 is to 4 ratio, the spacing and the depth. That is important, where the one horizontal space, 4 vertical drill depth. There is a mean empirical one. For loose material, this is a 1 is to 6 ratio. The ratio between spacing and depth, that's 1 is to 4 is required. For horizontal space, 4 is vertical drill depth. For loose material, it is 1 is to 6. So most pattern of spacing and it is kind of right. Okay. Next classification. What are the basic classifications of uh, drill machines used for surface mining projects, construction work, etc. can be classified the following way, depending on the principle of working. Percussive tape, rotary percussive tape, depending upon the type of prime mover, use diesel drive or drill machine. Most of the for convenient drilling electrical power supply also using. Sometimes they are using uh, diesel type also. Most of the mines in the power cable with the help of power application of the prime charge to the engine, the compressor movement. Depending on upon the means of power transmission, pneumatical operated machines are there. pneumatical operated, hydraulic operated machines are there. Electrical and operated machines in a combination with the hydraulic and pneumatic systems. These are the depending on the power transmission. Depending upon the power transmission, they're again classified into three categories. So this is the basic wagon drill. Wagon means the carrier is there, is connecting to the any tractor or other missions. It will be carry out, and where you required will be stand triangle shape. So it is convenient for the making of the drill the particular location. So most of these drills are in vertical only because of the maintenance of England is possible, not possible in wagon drill is concerned. This is another field system. The wagon drilling work is going on here. So this is drill head. So drill head here is moving against the vertical column. The chain sprockets are going on. The compressor here pressure is given to the cable through cable. So this is the attachment of the drill rods. The drill bits going inside. So wagon drill. It's another view. These are major parts of the wagon drill. Showing here. Here chain transistor transform chain sprocketing system. Rotation head. This is the basic rotation head. Another chain is given. Mast is given. This is a mast. Inclination quadrant, which uphill. So this is the button bits. They are using the button bits. Coming early sides. What the types of bits you are seeing? This is button type bits. These two are the front wheels. Another is the back wheel is there. Rear wheel, hydraulic pump, wheel adjustment for the sitting of system. Hydraulic jock is there here. A control box, spikes. So these are the basic operations of the parts of the wagon drill. right? Main parts of wagon drills: chain tensioner, rotation head, mast, inclined quadrant, chain, hydraulic jock, winch unit, control box, hammer, spikes, button bit, front wheel, hydraulic pump, rear wheel adjustment lever. Pneumatic operated wagon drills. Compressed air operated drills mounted on a mobile frame are known as wagon drill. The frame is usually mounted on the tire wheels. The figure shows on such a mission. They can be pulled up the operator and his helper to the hole site on the level ground. The size of drill hole varies from the 50 to 100 mm for a depth of 3 to 15 meters. These drills have separate compressed unit. Most drills are usual 3 meters long, providing the 3 meters vertical travel. This is about the wagon drill is concerned. The mast is capable of swelling from the vertical or horizontal position, and it can be kept at any angle between the horizontal and vertical, hereby thereby facilitating vertical, horizontal, or inclined drilling up to 40 degrees. The framework rests on three wheels. There is only one wheel at the rear which helps in the steering the mission, while the two front wheels are the main load bearing wheels. The mast of the drill is placed near the rear of the mission. The control units, such as the valves, are placed behind the mast. On the right hand side of the mission is a hand operated reciprocating pump which raises the mast from the horizontal to the vertical position. At the rear, there are two spikes which help to hold the mission during the drilling action. Blast hole drills, bigger drill missions which are produce holes to be blasted in order to facilitate higher capacity excavators are termed as the blast hole drilling missions. In fact, all drilling missions which make holes for blasting purpose should be termed as the blast hole drills. However, it is a common practice to refer only to bigger capacity missions. The hole diameter varies from the 100 to 300 mm up to a depth of 60 meters with a drilling speed varying from the 1.8 to 2 to 4 meters per hour. The main components of the drilling machines are as follows: drill bits, drill rods, mast assembly, feed mechanism, power transmission system, undercarriage unit. The main components of the drilling machines are as follows: drill bits, drill rods, mast assembly, feed mechanism, power transmission system, undercarriage unit. These are the basic components of the drilling machines. So, drill bit is a very essential. Drill rod is essential. Mast is essential. Feed mechanism also. Power transmission system is also. Undercarriage unit is also essential for the any drill. Any drill main components can be visualized. Right? Drill bit, which is very essential for the any drill because it is the hardest and first to attacking of the that rock. So that hardness is required. Depending upon the usage, there are different models and different types of drill bits available in market as per usage concern. So there are three type of drill bits are used in about type drill missions for wagon drill and down the hole drill for exploration purpose. Diamond drill most popular using. So there are a corset bit is the most using for wagon drill purpose. Tricon roller rock roller bit is another one. Button bit is another one. So there are a Carset bit and tricontroller roller, rock roller bit, and button bits. Corset bit. The drill bit in this case is essentially a cross bit tipped with the tungsten carbide and is an integral part of the unit. Led a corset bit as shown in the below figures. I are showing all the corset bits. It has 5 air holes at the center, 4 on one is the other side. This is the basic holes are given. These drills bit usually fit in the 1.5-meter long pipe, like a device known as a hammer. So it is fitted to the hammer. This hammer contains the piston. The entire hammer is contained piston and valve arrangement. During operation, uh, compressed air passes down the hole, drill rod through the flipper valve and exerts pressure on the piston, which in turn strike the bit. Air then enter the bottom of the piston through a passageway around the cylinder. When it is at the end of the down stroke and lift the piston up. In this position, the passageway is cleared and the entrapped air below in the released through the corset uh, bit and cleared again. The piston is then struck by an air stream uh, at its top and this force it down and the purpose of up and down movement of the piston gets going. In a pneumatically operated drill machines, the piston strikes can cause a bit about the 1000 times in minutes for full air pressure. This is the general the pneumatic piston is concerned. The drilling action in such a case, that is a movement of drill down the hole, take place on account of autominization of rock due to the constant pounding by the Carset bit. These bits have line contact with the rock and constant impact while breaking the atomizing wear and of the contacts. The cutting edges as well as the periphery needs grinding the future uses. So this is the Carset bit, is very clearly showing that there is a 4 holes here. There is a 4 holes is shown and center is another hole. This is called air holes. So it's showing the bit top view. This is a section view. This is a tricone roller bit, most popularly using bit. Air leg is given, groove rows, combs, apex rows, tungsten carbide button. These are the buttons are the made with the tungsten carbide to for a highly attacking purpose. This is a 3 rollers are there. There is a independently they rotating each other, and also the this also rotating to drill rod attachment to the prime mover. Then this is the original image of the tricorner roller bit. You can see easily understand the these are buttons, air hose. This is rotating independently each other. So some more parts I am showing here. protection, hand facing, gang protection, heel row, optional diamond, enhanced resets, bull bearing, floating bushing, ball retaining pin, jet nozzle, grease reservoir. So inserted buttons are there here. Cone is there. Tricorner roller bits. There's a cone means tricorner. Reaming a gauge. Nozzles are given. Leg protection also given here. Tricorner rock bit. It is a drilling machine which are electrically driven in a combination with the pneumatic and hydraulic system. The drilling tool is a tricorn rotor bit. This consists of three tricorneted cones placed 120 degrees each other as per the shown in figure, like 100 and the degree of one to each other. The surface of these truncated cones have a number of cutting teeth, and they are mounted on two bearing, one a roller bearing and other is the ball bearing. Roller bearings are positioned to support the radial load and free of thrust load longitudinally along the bearing pin. Ball bearings, which retain the cones of the bearings pin, resist thrust load acting longitudinally along the bearing pin. Bearing pin in a rock bit's head are forged integrally with each section of the bit body. The teeth of the cones are hard faced to give the resistance to the abrasive wheel. The bits are fitted with three air blast nozzles, which direct the air blast coming through the tailpipe to the bottom of the wall interaction. This helps the quicker and more efficiently removal of the cutting material. The size of the nozzle, the size of the nozzle required in the bit depending on the volumetric output of the compressor and its operating pressure capacity. The nozzle size should be such that it is not only clears the hole but also cool cool the equipment. Rotary speed varies from the 20 to 120 rpm for steel toothed bit and 50 to 80 rpm for the tungsten carbide bits. The normal life of such bits about 2500 meters. This bit is not repairable and has to be disposed for after use of 2500 meters. Bottom bit. So this bottom bit is these are the buttons are given. That is a button bits. These are the button. Most of the down the full tips. This is the most applicable thing. This is the button called button bits. Here showing very clearly button bits. There is a air holes also given here. Button bit. Button bits have a cylindrically bodies with a larger diameter head and the top, and the stem is a spline shaped. The head is a chamfered on the side. A number of hard metal balls in the shape of the hemisphere are penetrated on the head. A number of air holes are provided both on the head and the side flesh cut things from the drilled holes. There are certain vertical slots at the side to provide a passage for the cutting to come out of the holes. Rotational speed varies from the 10 to 25 rpm. The bodies are made of alloy steel and heat treated. The hole diameter varies from the 100 to 200 meters. mm, not meters. This whole diameter varies from the mm. So this is the drill mission for inclined holes also. It is a crawler mounted mission. There is a drilling rod boom is there. There is a mast. There is a drill head is going on along with that chain. This is a crawler undercarriage unit. Boom for the prime motors. Boom shovel mechanism. The shovel mechanism is there. So ultimately, this the drill is a basic functions are the main the drill bit. There is a drills um, a drill rod connecting to the drill bit. The drill rod and drill rod is moving from main moist against the chain sprocket is there up and down and through high air pressure is giving to the hoses. The connecting a rotary as well as percussive movement. So this is that field. They're showing the crawler mounted. This is the drill. The hole is making. There's a major machines going on. This is another at working place. So drill it as operating in the bench site. This is a vertical structure framework with a feed mechanism that is either the chain or hydraulic type. The rotary head air motor or hydraulic monitor electric motor is placed at the top and is capable of traveling along the feed mechanism downward or upward. Drill rods are attached to the rotary head through a coupling and a gearbox. The whole of this framework is held in position by means of hydraulic piston cylinder arrangement and is capable of swelling swelling the mast of in a vertical plane. Blast hole drills use heavier type of hollow steel called rod or pipe that is designated to convey a torque rather than the impact. The use of American petroleum institutions steeply stamped thread male tape on at the one end and the female tape at the other end. They are made of medium carbon feed mechanism. There are three types of such mechanisms are used in the drill missions. There are the pneumatic operating mechanism, hydraulic operating mechanism, and rope pulley operating mechanism. So pneumatically operated mechanism. Here I am showing very clearly. This is a belt pulley. Feeding motor is there. This is a sprocket. These are the chains. These two are chain. A rotor head is there. The gearbox and coupling is there. Drill rod is there. So there will be a transmission, the energy transmission through the drill rod and reaches the bottom drill bits. Pneumatically operated mechanism. This consists of an air motor, transfer system, and a chain drive. The air motor is driven by the compressed air, which drives the sprocket chain arrangement through a gearbox or a belt pulley system, as the case may be. The rotary head is placed on the chain, which reciprocating during the rising and lowering of the chain. Downhole drilling. The source of energy or rotating head is located outside the hole. Net energy efficiency become at least 20 to 30 percentage energy is lost during the transmission through the drill rod. This is called the transmission loss, and to overcome this transmission loss, a new system of drill has been developed. In this case, transmission losses are almost nil. The prime mover rotary, the drill rod hammer also rotates, but hammer inside the piston current directly attached to the bit. Piston move up and down by the compressed air circulated through the drill rod. So down roll hill basic advantage is here given to the pneumatic drill machine here. This is the prime energy giving. It is a transmission through. If your depth is increasing, the transmission of the power from here to here, there is a lot of weight on the motor, so that is unable to rotate it properly. In such case, the entire the system rotor head will be in the bottom. That's what we call down the hole system. The source of energy or rotating head is located outside the hole. Net energy efficiency become at least 20 to 30% energy is lost. So here is this case. So this is outside, not in inside the hole. Hole will be making here underneath after here. So so that the reducing that 20 to 30% energy utilizing by help of the downhole drilling mechanism. Through the drill rod, this is called transmission loss, and overcome this transmission loss. A new system of a drill has been developed. In this case, transmission losses are almost nil. The prime mover rotates. The prime mover rotates the drill rod. Hammer also rotates but hammer inside the piston directly touches the bit. The piston move up and down by the compressor air circulating through the drill rod. Pressure energy generated directly at the bit. This type energy is efficient as there are no transmission losses. The RPM, the revolution per minute rotary head is 20 to 50 RPM. Down the hole drill, this can drill holes from the up to 65 to 25 to 30 diameter in hard rocks. Here percussive hammer goes down the hole so that there is always a constant efficiency of energy. Constant absence of energy transfer from the piston to the bit. These drills are used for the drilling deep holes in open pits. Small drills are usually mounted on a carriage with a pneumatic type tire, which can be towed or self-propelled, while large self-propelled drills are normally mounted on the crawler tracks. The crawler mounted drills can be negotiated gradient up to the 1 in 2.5. So that is one advantage. But I have a traveling speed of only 1.6 to 5 km per hour. The speed of the traveling vehicle is less. The carriages usually have a folding mast which can be hydraulically or mechanically adjusted in the inclination for the inclined hole drill. Though some missions are designated exclusively to drill vertical holes, the drill carriage in some of the large drills, such as a roll or drill master house, the main power source, the drill, the hydraulic pump, as well as the compressors. While in the smaller units, the compressor is mounted on the separate carriage and is usually towed. The drilling hammer in the simplest form comprises a cylinder in which moves a piston. The air supply to the cylinder is through a simple valve, flap valve. When the valve is on its bottom seat, air passes through the channels in the cylinder wall and enter the bottom part of the cylinder through the inlet holes. This pushes the piston up and down. When the piston on the backward stroke closes, the upper exhaust ports, the air at the back of the cylinder get the compressed and pushes the valve against the upper seats. Those supply air to the back of the cylinder. The exhaust air from the cylinder is coursed through the internal holes in the bit and used for the flushing the hole. Provision is also made for supply of the fresh air directly to the bit for flushing of the holes. This is one advantage of the hole, cleaning of the hole. So down the whole cross section I am showing here with the parts. It is attached to the nearer to the where the bit, almost near to the bit. So various parts can be observed here. This is the A side and B side, the internal structure. So this is the drill bit retarders, inlet hole, cylinder valves. Here we can be easily understand here the percussions and the rotation and flushing, cutting. This is the basic operations. But in this there is no complete. The head will be nearer to the drill bit, so that energy transmission is more attacking of energy, not any loss of energy, as per the conventional type of drilling method. So down the hole drill is inserted in the drill hole. So this is the drill, down the hole drill. Here you can observe here. This is the drill bit. Main exhaust system is also there. Air pressures. So flushing will be complete, and by through this one dust and other thing, cutting metal come outside. So there's some more elaboration of the down the hole drill. So this is rotation mechanism, the feed mechanism, air flushing. So drill bit, piston. This is drill bit piston. So some more features can be elaborated here. The simple diagram. This is the drifter. The percussion action is happening. The piston through piston. The feed mechanism going on. The rotation also. So percussive rotation both are required for the percussion is always giving the penetration rate. The rotation will be giving the hole cleaning. So both the percussive and rotation. So extension rock, the flushing material come outside. So this is the drill bit come down the whole drill bit. Yes, come down the hole drills have become very popular in the drilling large diameter holes in a percussive mine, particularly in a hard rock. The separate rotary motor, which can give the speed varies from the 0 to 120 RPM, helps in proper indexing of the bit in the rocks of varying hardness or by suitably adjusting of the rotational speed. Provision can be made of converting these drills purely rotary drills for negotiating soft formation. Higher hammer power has been achieved even in a relatively narrow hole drills by use of double-headed pistons, a piston with the two head moving in the two independent cylinders placed on the one after another, which is increasing the efficiency pistons area. Through not prevalent in open cast mine, down drill using high air pressure of order 70 to 70 kg% may have been manufactured and up used for deep hole drilling in hot rocks. So this is a basic thing. The applications of the downhole drill. The application of downhole drill is that can be used to drill holes 125 to 300 mm diameter and depth varying up to from 60 to 12 meters. Generally, it is used for the downward drillings only. So with this, I'm going to concluding that most of the types of we are summarizing here once again. Already we have discussed different type of drilling missions with respect to depth and diameter ranges, and also different type of drill bit types. There is a bit is a corset bits and also buttons, tricorner roller bit. Its features and what are the silent images of the parts of that and classifications. Also, we are all covered here, and also the basic nature of the down the hole drill. What is the advantages of the for deepening holes, the energy lossing for transmission of energy from the outside to the inside of the hole. In that case, your specially made uh, drill mission drill head is inserted into the nearer to the drill bit so that such loss can be avoided. So with this, I'm going to conclude. You have to quiz one question. So simple purpose. The followings are used in rotary drilling with the drag bits, with the roller bit, with the diamond bits. So most of above three are using above rotary drilling. It's helpful for your examination point of view as well as competence. So simple assignment to take, try to and mention that all the what are your gone through so far. Write about the different drilling missions used in mines with a neat sketch. Explain the each and every one so that you can able to uh, know understanding the basic things of the drill missions used in the open cast mine. Now at a glance you see the some more figures which is already you are covered in this subtopic. That is repeating that these things. Right. Now I'm concluding this chapter. Uh, Once again, you go through the different source of applications of missions in different formations of the rock. I wish you all the best today, enjoying the class. Thank you.